EPLAN. Efficient engineering is when a plan becomes EPLAN. Interesting. The idea behind the scene is we all want a perfect panel. For this, we need a digital twin. What this will allow us to do is to create the documentation to get the perfect panel. What we don't want is this. We don't want wires that look like this and that are hooked up like this. We don't want the electrician to figure out how he has to do the wiring, nor do we want too many wires in one hole. This could actually burn down the whole thing. So what and where do we have to start? We have to start basically with EPLAN. We have to start in the schematics itself. So if we take a deeper look into this EPLAN schematic, we will see how EPLAN works. EPLAN has a bunch of devices. Every device is connected to another device, and a wire hooks up the two of them. If you have an additional device, which gets numbered automatically, an additional terminal that it also numbered automatically, you have a new wire. This new wire can automatically be numbered. So far, so good. These are simple wires that actually hook up between two devices. Now we have to think about the next level. How do we feed these two circuit breakers? Well, let's take a look at a couple of options. First option would be this one. We feed CB420 and then we jump over to CB422. Next option would be this one here, where we actually feed both of them from G425. Or we feed everything from the top, but now we have a problem. We have three wires going into this G425 plus connection point. So how do we now resolve it? In EPLAN, we have what we call connections, connection points, connection symbols. In IC, they've given us a few different ways to display them. Now, of course, if I don't display anything or a dot, I don't know where the wires come from, and I have to figure everything out when I'm doing the wiring. I'd like to help the electrician, and this is the way to help them. So in IC, this is the drawing that is shown by IC. So technically, let's take an example on here. We have 1, 2, 3 contacts. They are actually connected in a daisy chain. K1 is connected to K2. Q1 and Q2 are also daisy chained. Let's come back to our EPLAN example we just had earlier. Here, the T node I will be using here will draw a line into CB420 and into 422. So the line goes off here to the right. So the connection symbol I'm looking for is the T node right. So this T node, as I place it, will have a certain shape. This shape tells EPLAN how the wiring is done. If you double click on this, you can see we have several different options. Now, if we take this option here, what would this mean? This means that all the wires originate from up here. One goes in here, one goes into CB422. This is exactly the option I was telling you that does not work. The option that is and suits best here is this option here, where the wire comes into CB420, goes out to 422, and then continues. And this, of course, if I take these wires as they are here, and I rerun, let's say, the wire numbering, you will see that even EPLAN recognizes the different wires. There's one here, one here, one here, one here, and one here. So the T nodes are properly placed on this side. When we get to a more complex control, like here I have a small example of a small control, we have, in this case, let's look at the drawing here. We look at the back of the door and we look at the panel. So of course, this is a typical classical case where you have some push buttons on a door and you have some relays on the panel itself, on the backplate. And in between, you have some terminals. Now, typically, I want to avoid wires going between the backplate and the door. So when it's possible, I try to limit the number of wires that go between the backplate and the door to only one if it's necessary. Hereafter, I try to connect within the door, or I try to connect within the backplate. So technically, if we go back to our schematics, this is what I'm trying to do here too. So if you look at this drawing here, these push buttons are indeed on the door. I actually created here a small location box that specifies door, just to help you out a little bit from a schematic perspective. Now, this schematic, okay, shows what is exactly on the door. The two push buttons, and then the terminal, the coil, and the contact of the coil are actually on the back plate. So technically speaking, when we carefully look at this, we have a push button that goes through a terminal and then down on the back plate. We have to think a little bit here, and we have to think about the contact. The contact, is the contact closer to the coil or to the terminal? Well, this varies, right? It really depends, because when you think about it, the coil has a connection A1, has a connection 14. These two connections may be very far apart from each other, and because you have to go from the top to the bottom, and maybe the terminal is in between and could actually link them up. So you could theoretically change the T node that is here in different ways. The one thing we're doing though is on the left hand side here, you can see that we have two different 24 VDCs. We have two lines of 24 volts. One line represents the 24 volt on the backplate. The other one represents the 24 volt that I brought up to the door. So once I bring 24 volt into the door, and then I try to hook up through the door. So technically speaking, here I'm daisy chaining within the door on this power line. Now, when it comes down to the contactor is on the back plate. So I'm not using the same 24 volt hot on the back plate. I'm using a different one. Technically, these two may or may not come from exactly the same source. Sometimes they do, sometimes they don't. Doesn't really matter if they do or not. They are not physically in the same location. One is on the door and the other one is on the back plate. So it's better to split them like this, because in real life, you will not go from the door back to the back plate, from the back plate back to the door, etc. You're not going to switch constantly between the two of them. You're going to keep the 24 volts on the panel and the 24 volts on the door together. And here, of course, the T nodes, as you can see them here, they show a daisy chain.